webinar series. Today's topic, disaster recovery, implementing DR across on-premises and AWS. I'm your host, Maya Kabasi, with the partner marketing team here in Seattle. I'd like to start with a couple of housekeeping items. This webinar is being recorded, so all lines are muted. However, you can submit questions anytime during the webcast. Please take a few seconds to locate the Q&A tool. We will take time for questions at the close of the webcast. And the webinar will be available on demand. We will be posting it on YouTube, and the deck will be available on SlideShare. Tomorrow, you will receive an email that includes the appropriate URL, so no need to take notes right now. I'm very pleased to be joined by Abdul Saeed, Principal Solutions Architect from AWS, Brad Helliker, Director of Cloud Business from Attunity, and Ken Linger, Director of Enterprise Technology, LeaseHawk. On the agenda, overview of disaster recovery on AWS, how to use Attunity to make data available across environments, a live demonstration and a case study of LeaseHawk on best practices for implementing DR on AWS, and we will conclude with a Q&A. For those of us who are just joining us, I just want to repeat the topic of today. Disaster recovery, implementing DR across on-premises and AWS. So without further delay, let me pass it on to Abdul. Take it away, Abdul.
Thank you, Maya. And good morning, good afternoon, depending on wherever you are, and thank you for attending the webinar today. I'll start talking first about, why DR and why it is important. I'm pretty sure most of you who are working on any kind of enterprise systems or web applications, any kind of business that depends on IT to run its business has come across an outage caused by outage of IT infrastructure. When there is an outage of IT infrastructure, it affects the business, and it affects the business of all kinds and sizes. And always it's quite expensive. And how costly, how expensive this outage depends on what kind of business it is. The kind of outage, IT outage that costs money for an e-commerce website would be different from the IT outage cost for a company that uses IT for running its payroll and running its financial system. Again, it's going to be very different for a company that depends on its IT infrastructure to do security or stock transactions, in split milliseconds. So the actual cost of the outage would be different, but there is always a cost associated with it, and it's always very detrimental for running the business. So let's take a look at what normally causes downtime. There are various factors that affect the infrastructure, which results in outage that causes the downtime. Many times it's natural disasters. We have first-hand experience recently here in the U.S. With Superstorm Sandy, and recently in this winter, really bad weather, tons of snow in many parts of the country, and freezing rain and ice in warmer parts of the country. So these are things that could affect the operations of the infrastructure, power outage, floods, whatever else that are results of natural disaster. And then there are security incidences. The hackers of all kinds are always trying to get into companies' infrastructure to cause havoc, steal information, do whatever they can. And despite all the security measures that the companies or enterprises and organizations take on, they seem to tend to get around these things. And then there are vulnerabilities that are part of the software or hardware itself, just like the one that we saw with Heartbleed very recently. And the third one is equipment failure. Just like things that can happen to the equipment that we use on a day-to-day basis in our hands and around us, equipment failure occurs all the time in data centers as well. This could be the power supplies blowing off, the network infrastructure coming down, the server itself failing. It could be, power outage, network outage, any kind of many different things. But probably the largest cause of infrastructure outage and downtime is human error. Somebody by mistake deleting some records or some tables in the database, or just stripping over something, pulling a code, or that results in a hard disk crash, or somebody mistakenly overwriting some kind of information that shouldn't have happened, somebody opening some ports or closing down some ports that should have been there to start with. So all kinds of human errors that also results in IT downtime. So the disaster recovery strategy that we work on should be able to cover all these aspects that result in downtime. Let's take a look at some of the terminologies that are commonly used when it comes to DR architectures or DR implementation. This is very important because your DR architecture that you'll be choosing will depend on these three parameters that I'm going to talk about. The first thing is called recovery time objective, or in short, it's called RTO. RTO is about the amount of time that you are willing to spare between your infrastructure going down and you having to be able to working, seamlessly. So, for example, if you can take a 3-hour downtime when something goes wrong with your production environment, between the production environment going down and your DR environment taking over, then your RTO is 3 hours. If you cannot take more than 5 minutes of your production going down and your DR side being active, then your RTO is 5 minutes. And this varies from business to business, from environment to environment. Let's say you are running an e-commerce site where you are actually selling stuff on your website. You don't want your website to be down for an extended period of time. So in that case, your RTO has to be minimal. You think, oh, maybe we can take an outage for 10 minutes. So you should be architected to fail over to your DR infrastructure within 10 minutes of time. Let's take the example of a payroll system where you run payroll every 2 weeks. This is production system. There, if the system goes down, you can comfortably take a 12-hour time between your production going down and switching over to the DR side. In that case, your RTO is going to be 12 hours. If you have a content management system, production system, where your organization shares documents and uses for collaboration, if that goes down, maybe you are fine for 48 hours because people normally have these documents on their machines, so you can recoup some of those documents that were lost from what is locally available from the authors who created them. Then go back to the documents from 48 hours ago. So in that case, the RTO is going to be 48 hours. This number and this value really matters because that determines the cost and agility of your DR system. The second very important term is recovery point objective, or RPO. So RTO versus RPO. RPO is all about data. It's the amount of data that you are willing to give up if something goes wrong. Again, like I mentioned about the content management system, you wouldn't worry about 48 hours worth of data because you are confident you can go get it back, and even if you lose some, you wouldn't really care that much about it. But in some kind of system, for example, for financial reporting, your financial data that you need to provide to IRS, and you have to base all your financial transactions and reporting based on, you probably don't want to lose any data. So your RPO is going to be 0. So basically, you don't want to lose any data. Now, again, the architecture that you will build for your DR system is going to depend on your RPO as well, based on how much data you are willing to let go. An example for that would be the replication strategy. For example, you have a system running with a database. You have set up database backup for every 3 hours. So you have backed up your database 3 hours ago. Now your production system goes down. You bring up your DR system based on your backup, which was taken 3 hours ago. What that means is you have the potential to lose 2 hours, 59 minutes of data. So that 3 hours is your RPO. Now, why pick and choose between this? Why not always go for the best, the lowest RTO and the lowest RPO? Obviously, for financial reasons. The lower the RTO, the lower the RPO, your infrastructure for, or your design, your architecture for DR is going to be most expensive. In a lot of cases, it's worth doing it, especially when you come to AWS, just because of the tremendous capabilities AWS has when it comes to elasticity, scalability, and on-demand cost. The DR implementation cost on AWS is extremely small compared to what it normally costs to do that on-prem. Now, because of this, you'll be able to have the lowest RTO and RPO in many cases. But again, you want to save as much money as possible wherever possible, and then also have DR sites available for as many environments as possible. If you can cut down DR costs by 50% by optimizing RTO and RPO, that could mean that now you can have DR sites for more environments in your organization. So this is one place where most organizations take shortcuts. I'll talk about it a little more in detail in some of the next slides. So let's take a look at the conventional disaster recovery sites. Normally these cost a lot for many different reasons. One, it doesn't make any sense to have your DR site right across the street. Though some organizations do that, I don't call it a DR site. I call it a disaster waiting to happen. Because if there is a flood or a power outage or whatever else, you want the other site to be available irrespective of what happens to your primary site. So you want it to be in a completely different geographic region where whatever happens in your primary region is not going to affect. Now, this adds to the total cost because now you want to set up your DR site in a place where you don't have any personnel or contacts or direct business versus your primary region where you already have agreements and connections and contacts and whatnot. The other thing is, the DR site is to seamlessly continue your business. What that means is you want to have your DR site at least at a scale of 30 to 50% of your production side. If you want to handle the complete volume just like production, you need to have it at a scale of 100%. If you can take some degradation in performance, you can probably choose to go to 30 to 50%. So if your production environment is going to cost you $6 million, even at 50%, it's going to cost you $3 million. So it's high cost and it's just sitting there, so very low ROI. Because it is so expensive to implement DR, most organizations choose to do it only for very critical systems or the most critical system. And though there are a lot of other systems in the company where DR would be really desirable. Whereas coming to AWS, like I mentioned before, because of the unprecedented capabilities when it comes to flexibility, when it comes to the scriptable infrastructure, software-defined networking, on-demand cost and scalability and elasticity, there are a lot of different things that you can do on AWS that could never be done before, resulting in substantial cost savings for implementing DR site. So one of the things it does is it cuts down your DR bill. The other thing is because you are saving so much money, now you can go and implement DR sites for the other environments, the environments other than the extremely critical ones. One of the greatest things probably AWS brings to the table in terms of DR is the geographic distribution. AWS is distributed across 10 geographic regions. So now implementing your DR site in a very remote region, let's say if your primary site is in Boston, setting up your DR site in San Francisco or in Brazil or in Singapore is just a click away. You can do all this right from your desktop. Bringing together all the capabilities and the flexibilities available on AWS, we have put together 4 different architectures that we think suits very well the different use cases when it comes to DR. These vary in prices and cost and RTO and RPO. Of course, the cost depends on the RTO and RPO. The 4 architectures are backup and restore, pilot light, warm standby, and multi-site. And in that order of cost. So backup and restore will be the cheapest, but it'll have the largest RTO. Pilot light will be the next cheapest, and then warm standby comes next, and multi-site is going to be the most expensive, but still much more cheaper than probably what you are doing today. Attunity is our partner who have a lot of products and services that caters to our customers who want to move their DR site to AWS. Let's take a look at what Attunity has to offer and how you can leverage Attunity products to bring your DR site to AWS. I'd like to invite Brad to continue from here.
Thank you, Abdul. So my name is Brad Helliker, and I'm Attunity's Director of the Cloud Business. I'll be joined today by our engineer, Riza Khan, and together we're going to demonstrate how Attunity Cloud Beam can enable your organization to make information and data available across on-prem and Amazon environments. So the first classic question for any organization shall be, for disaster recovery, what are your goals? And the primary goal is, of course, to avoid or minimize disruptions to business. That is, keep your business moving 24/7. And then, per Abdul's presentation, a secondary goal may be to minimize DR-related costs and make the best use of standby infrastructure. And this will be demonstrated by LeaseHawk and Ken. So if they are our goals, how shall one achieve them? The first mechanism, of course, is to make infrastructure rapidly available. And thank you to our friends at Amazon. This is now very possible. The second mechanism would be to minimize the potential for data loss or potential gaps in data. To solve that, you may leverage Attunity Cloud Beam, which can make data available across your production and DR environments. So when setting out to design a plan, let's take a look at some considerations. Perhaps your most precious asset within IT is your data. It is unique to your organization. And within your data, that most precious asset unique to your organization could be the data living within your database servers. So consider here our on-premise environment. We will look to database servers, your app servers, web servers, and then storage. In the context of Amazon, Amazon satisfies target environments for DR, including database services on RDS and databases running on EC2. Amazon makes EC2 available to support app servers and your web servers, and then, of course, storage options including S3 and EBS. As Abdul indicated, there's value in designing a DR strategy that is across geographies, and Amazon provides plenty of options there, supported also by Attunity cross-region. So when an organization sets out to establish a disaster recovery plan, especially across regions, common challenges come forth. Very consistently, organizations will encounter a certain level of complexity. Further, it could take perhaps too long to make data available across different regions and environments. Of course, there is a cost associated with moving that data, making it available. Depending on your tolerance, very few organizations find that there's enough real-time data there. There could be potential for gaps in data. And to achieve the top 4, there's often a lack of developer resources. So given those challenges, I'd now like to present the option of Attunity Cloud Beam. I'd like to present this in 2 separate sets. First, I'd like to dive into structured data, in this case replicating from a source to Amazon RDS and or a database residing on EC2. Here's a common topology. You'll see in the bottom half a source environment, very often on-prem. That source environment can contain your source databases. And then you can have target environments living in Amazon. It could be on RDS, perhaps on EC2. It could be in one region. It could be in multiple regions. To achieve replication between a source environment and Amazon, Attunity requires the installation of Attunity Replicate software on an independent machine. That's a zero-footprint design. They can look to a source database, efficiently replicate data to a target region, broker data via an Attunity Replicate machine within Amazon, running it to your ultimate target, which could be RDS or a database residing on EC2. You'll see here also that it's the same software solution that can supply data to Amazon Redshift. Let's look at that data flow. Again, we have a source and a target. We'll install Attunity Replicate in each geographic location in each data center. And from there, with a simple job configuration, which Riza will demonstrate, it's a matter of looking to a source, transferring data, and writing it to the target. The same can be within the region. That is, if your source lives, if the data already lives within Amazon, Attunity can broker it to another target, be it to S3, RDS, and or to Redshift via S3, to Amazon RDS and or that database living on EC2. So what makes Attunity efficient and superior in the way replication is facilitated? Attunity looks to a source database and can do a bulk read, processing in memory, applying any transformations or filters, and then manages simultaneously a bulk load to your defined target. Attunity also has a very efficient change data capture, such that if real-time changes are presented on the source, Attunity can look to change logs or transaction logs and move micro batches from that source via memory to the defined target. Now, when moving data across the WAN, Attunity prides itself on an optimized transfer protocol. This protocol is designed to accelerate and guarantee delivery. It applies a variety of mechanisms ranging from Amazon's multi-part transfers to concurrent sessions and streams, compression, recovering at a 64K block level with encryption applied. The performance gains are conservatively 10 to 12 times over standard copy, and we've seen commonly 50 times over that of a standard copy. So if your goal is to make information available between production and DR, you need it there as fast as possible. This will be one significant advantage. This is all about information availability. You'll see through the automation, the click-to-load design, that Attunity will enable your organization to make that information available for perhaps DR purposes in the target region. You can overcome the data transfer bottleneck and realize a quick time to value. At this time, I'd like to pause and introduce Riza, who will show you how simple it is to look to a source and supply data in near real time to a defined target.
Thank you, Brad. One moment, please, as I switch to the demo environment. So currently, you should be seeing a remote desktop session that I'm sharing. It's actually an EC2 instance running in Amazon. And on there, I have defined or installed the Attunity Replicate software. So we're going to take a look today at how we can use this, this server and the technology that Attunity brings to actually load data from one Oracle server to an Oracle RDS instance running in Amazon. So we'll begin by actually defining some databases. So if I click on Manage Database, I can begin by starting to define my source and target definitions for this environment. So let's give a second here. Okay. All right. Okay. So if I go ahead now and hit Add Database, I can begin by defining my source. So I'll call this Oracle source. And select from the list of source machines that I have here, Oracle. And then my connection string would simply be how I need to connect to that database. In this case, it's running locally on this EC2 instance. And then I define the username and password to connect to that data source. So I'll just test that very quickly and verify that everything's okay. So that looks good. And then what I'll do is quickly define my, my Oracle client to talk to the Oracle RDS instance. In this case, you can see here the definition that I've used in my DNSnames.ora file. So I'll use the ORCL as the data source name. So I'll add a new database here and call this RDS target. And select Oracle target here as well. Everything is completely transparent from us because we're using the Oracle 64-bit client. And then my username and password. So I'll test that and make sure everything's okay. In this case, no. All right. So once I've defined my source and target, I can actually begin designing my replication task. So in terms of the definition, it's very simple and easy to use. We call this basically click to load. So I'll call this my task. And then as you can see here, I've selected to do both a full load and apply changes. I'll just click OK, and then this brings me into the actual definition. So I'll drag my Oracle source into the source definition. And then add my RDS target, go into my table selection, and be able to then select which data I want to replicate. In this case, I have data in my HR schema. So I'll just select here a number of tables. I can use all or just select a few and add them to the number of explicitly selected tables. I'll click OK, and then that's it. I've already defined my task. However, if I wanted to do some additional processing of this data, I could go into my table settings and set up some transformation. So I can actually transform the data by using all of the different kinds of expressions, including adding a new key, or adding new keys, or adding new columns. Or I can go into the filter and use the filter to actually ensure that I'm including or excluding data based on specific data values that I want. In this case, I'm going to load everything as they are on the source. So I'll just go ahead now, and before I run this task, let's connect to that Oracle RDS instance. So just hit OK, and now you can see that that AWS user is there. None of the databases or the tables actually exist. I'll switch back now to the Oracle, to the Attunity Replicate server, click on the Run button, and this begins the actual replication task. As Brad mentioned, we're using the bulk load and the Oracle client mechanism in order to do a full dump of the data and then process that in memory and then start loading the data already. And as you can see, you have complete information here and audit that shows you exactly how much data was loaded and how many records for each table were loaded as well. So by going back to my target, I can refresh, and we'll see now that those tables will actually be created. So it's taking a little while here to refresh. And we can actually run here now a query that gives me a count of the actual number of records, which is 107 for the employees table. So let's go back, and there they are now. So you can see the actual tables were created. Now let's see how we can actually leverage the same functionality here to capture some data from the source in real time. We've got a little utility here that allows me to add additional records. So if I were to insert 1,000 records here and hit the Go it will actually now insert 1,000 new records into that table. I can also update that by increasing the salary for these employees. And if we switch back to Attunity Replicate, we can move now directly into the change processing. And you can see already that some of the data were already applied, and now the updates were applied as well. And the apply throughput and the latency gives you an idea of how many records were actually replicated. Similarly, if I wanted to actually delete some data from the source, I could go ahead and delete that as well from the source database, and we'll see that being reflected here and captured in real time by Attunity Replicate, and then actually applying those changes back out into the Oracle RDS target. With that, I'll pass you back over to Brad.
Thank you, Rita. Actually, I'm going to proceed now to pass it back to Ken Linger.
Thank you, Brad. Okay, see if we are sharing. All right. We'll say this. All right, can everybody see this? I think so. All right, so LeaseHawk is, we met Attunity at the AWS conference last November, and LeaseHawk was a perfect customer for this product. We've inherited a large database from the basically through acquisition, and we had to pretty much move a large amount of data from our on-premise database into Amazon Web Services. Our company basically does a call tracking service. We route millions of phone calls every month. We have a lead manager, lead score process. Customers are expecting our systems up essentially 24/7. We found that moving the millions of records, I mean, what we just saw in the demo was fantastic. It looks great on 1,000 records. Obviously, everybody out there has millions of them, and getting that data into AWS looks like a daunting task for us. Our situation, basically, we have an Oracle shop today. It has an on-premise database in our own data center running here in Arizona. We had to migrate all of that data into Amazon Web Services, and we were using our Oracle RDS for that. Everything in our environment was redundant. We had multiple phone systems, multiple reporting systems, everything, web servers, app servers, all that stuff. The one exception, of course, was our Oracle database. So we knew it was a single point of failure. We wanted to get that removed from that list, and AWS was a perfect fit for that. We were going to move that to AWS and RDS for getting that disaster recovery out there, and we wanted to get the company ready to cut over all of our systems over to run in AWS and get out of our data center entirely. Of course, the goal was to do this as fast as possible and avoid any disruptions like data loss. In a major cutover, we were looking at basically doing a data dump of our entire database, copying the data up to Amazon, and doing a reload. In all of our tests, that was taking about 14 hours. We wanted to get the DR that was talked about earlier, and we also, of course, wanted to do it on a budget. Our alternative was to essentially expand our internal investment on hardware and spending more money on Oracle licenses, buying additional hardware, buying additional data servers was just out of the question. When we talked to AWS, it quickly became obvious that that was the best choice for us. Utilizing the multi-zones and eventually multi-region for both our app servers and our database servers, things would go perfectly for us, and it was the direction we wanted to go. Again, scripting all of this out, even when we had it fully automated, was taking about 14 hours, and the process resulted in large data gaps due to disruption in the business. Essentially, we could cut off the services through the data dump, keep everything running. At that time, calls were still routing and everything, but now during that whole process, the data's already been copied, and we're not logging any of the contacts from the clients. CloudBeam here brought in a simplified automated process that you just saw, and we used their bulk load process. We ran several tests with it, then we did our entire database, and it really is as easy to set up as it was shown there, and it took about 14, instead of taking 14 hours, now we're looking at about a 15-second time to bring the database up to date. The latency there, even between true regions and the databases with hundreds of tables and millions of records, that latency is the true 15 seconds that we saw there. Obviously, the operational efficiency is better, the disruption to our business is gone, and the data integrity, we verified this numerous times just as soon as we could not believe how fast it was going and how perfectly and how shortly our cutover time had become. And now our future is basically expanding the AWS footprint, moving on to multiple regions. We're looking at the Attunity product again to now replicate data from from Oregon over to Virginia, for example, or maybe someday into the Asia region, so that we can now have our true redundancy geographic all over the planet and still provide services on a 24/7 basis to all of our clients. With that, I will send it back to Brad. Brad, I think you're next.
Got it. Yep. Thank you, Ken. I appreciate that. So now that we have conquered the world of structured data, let's convert into the world of unstructured data and file systems. So Attunity provides solutions to replicate data, often files and file systems, from source environments, often Windows and Linux, to Amazon S3 and systems living on EC2. That can be anything from collaborative files to applications to content, and then, of course, to storage. So let's take a look at some of these topologies that exist in the real world. Given a source, Attunity can look to a variety of sources that exist as file systems. We can also take backups of databases as well and prepare them as flat files. Attunity then has the ability to accelerate and replicate that data up to, can be via an AMI machine to your S3 bucket and or to an EC2 target. So it can be on-prem to Amazon and then Amazon source region to a target region. How does this look? Attunity has a client that would install in the source environment, can install on Windows, Linux, and or look to a shared storage device in the network. If you have a source environment and a target environment, Attunity uses a comparative snapshot technology that's extremely efficient to identify the differences between the two environments. Once those differences are determined, we create a make list, and then we optimize the transfer of those differences from a source to a target with reporting and monitoring in place. And then you'll see in a moment, you'll have an option for ongoing automated replication for whatever job configuration you may have. Again, Attunity prides itself on the actual performance. We have up to a gig transfer speeds, and this is achieved through the multi-part transfers, concurrent sessions and streams, compression, etc. We've moved, for some customers, up to 12 terabytes in a matter of a day. Configuration options are critical in the enterprise. Attunity provides management layers to manage uploads, distributions, and then downloads for that day you hope you never see in terms of recovering your data. We also run in different synchronization logics, and then we provide the automation options of scheduling. You can run once, scheduled, real-time, tie in other processes, and then also submit jobs on demand. I'd now like to reintroduce Riza, who can show us the interface for moving files.
Okay, thank you, Brad. Let's switch back to my demo environment here and take a look at another application. This one is related specifically, as Brad mentioned, to unstructured data, so files replication, addressing any needs around the application space for replicating data. So switching out from this web interface, if we take a look now locally on my machine, I have a website that I want to replicate. It's actually part of Attunity's portfolio of products. We have a web UI also that this product uses. Right now you can see that this web UI has not been loaded. It's an actual application on the system. So let's take a look at how we can actually use Attunity Replicates to replicate this data. If we have a different application here called actually Attunity RepleWeb. And what I've done was define a single job here that will be scheduled on demand for me to initiate a replication job. If we right-click on it and modify it, we can take a look now at how easy it is to actually define. I simply need to specify a source directory, the actual name of the edge, and then user credentials to connect to that edge, and then what actual target directory we want to use for the unstructured data. As you can see here, there's a large portfolio of different targets that we can address, including HDFS and other cloud infrastructure or resources as a source or a target. Once you've defined the source and target, if you wanted to also replicate additional application resources as part of this job, you can go into the properties of the job and begin to set up some of these additional settings. There's lots of configuration settings here. We're not going to go over each and every one of them in the interest of time, but what's important here is to take a look at a couple of very significant or very useful features. First, on the Files tab, you have the ability to include and exclude files and folders based on specific criteria, whether it be wildcards or actual names of the files and folders. You have the Performance tab, which comes in 3 flavors: the LAN transfer engines for regular transfer from server to server in a LAN, or the WAN transfer engine, which allows you to add some additional settings such as bandwidth limitations and differential transfers, and enabling SSL to encrypt that transfer as you're going across low latency networks, or the large file accelerator, which provides all of these transfer acceleration capabilities that Brad mentioned in his PowerPoint presentation. As you can see here, it also includes the ability to use SSL for these encryption, for these transfers as well. In addition to that is the ability to enable IIS configuration replication. In this case, I've actually selected to replicate the RepleWeb R1 web UI as part of this job. And if I wanted to perform any configuration transformation for the web config files, I can also enable this by using the config transformation capabilities here. Finally, you have the ability to include any pre and post commands that will be a part of this. So if you needed to stop IIS before the replication, run the replication job, and then restart IIS, you can integrate these kinds of scripted processes in a non-interactive method with one of these replication jobs. And for your safety net, the ability to use rollback to save and record all of the data that exists on the target before you make any changes. This way, if you wanted to roll back any data that was published at a specific time, or since the beginning of time, you can actually use the rollback mechanism to get back to a working state in case bad code was published. So we're going to actually take a look at some of the data moving now. That's in addition to that, there are other scheduling options that you can define, such as how often you want this to run, or to run it in continuous update mode, meaning as files are created on the source, we actually pick them up and replicate them in real time. But here, we're just going to let this job run on demand. So the way it works is I'm simply going to right-click on this job and choose the ability here now to submit it, and submit now. And what will happen is a new instance of this replication job will be submitted. I can then double-click on it and get information about this job as it's running in real time. As you can see, we have actually replicated those files very, very quickly. We use our comparative snapshot technology in order to know when, which files have changed since the last replication. So we're only going to be replicating the deltas since the last change was made to this specific application. We have very detailed reports, including the general report, which will show you all of the information you need in terms of this job, when it started, who started it, and how many files it actually transferred. And each individual transfer report will give you a list of all of the files that were replicated as part of this job as well. So you can use this to actually create auditing information, all of which can be written permanently to a database in the back end to give you visibility of your replication jobs as they're happening. So if I switch back now to my web UI and I refresh it, we can actually see now that this web UI has been updated and it's got my password saved. So I'll just go ahead and log in now, and I'm actually able to use this web UI to even submit additional replication jobs if I wanted. That concludes what I wanted to cover with you today from a file replication perspective. I'll turn it back over to Brad. Thank you.
Thank you, Riza. So actually, maybe I can reintroduce Maya to host the Q&A.
Thank you very much, Brad. Before we start the Q&A, we would like to put a very quick poll to measure your satisfaction and expectations from the webinar. Just take a few seconds. We'll wait for you guys to finish that. All right, thank you very much for taking the time to take the poll. And I would like to open it up for Q&A. Let's start with Brad from Attunity. Brad, would you like to look at your inbox and cover some of the questions you have received? You have quite a bit, I know, so just cover a few as much as you can, and then then we'll cover some questions that were addressed to Abdul.
Sure, thank you. So I do see quite a few nice questions. Among them, from a viewer named Dave, any capability or plans for local Hadoop to remote EMR? You'll see that within the Attunity Replicate solution that you do have the ability to look to an HDFS source and replicate to a remote HDFS target. We also have customers using Attunity to load data to Amazon S3 and EMR clusters running on EC2. Shall we alternate to maybe Abdul?
Brad, continue. It looks like most of the questions we have are specifically about Attunity products and the capability. So I think it'll be appropriate for you to just continue answering as many as you can.
My pleasure. Thank you. So it says, what file systems and OS are supported for both structured and unstructured? So for structured data, common sources and systems include Oracle, SQL Server, MySQL, and others. For the unstructured data, most commonly Windows, Linux. There are others as well, including attached storage. Let's see here. We have some good questions. So there's a question coming in. Are there tools? Are these tools GUI only, or are they command line as well? For the Attunity Replicate for structured data, database replication, you'll have the option of a GUI and command line. And then for Attunity RepliWeb for unstructured data, you'll have the option of a graphical console as well as a web UI, command line, and API.
So Brad, one question that is repeated quite a bit is about cost. Could you quickly cover that a little bit?
Sure, my pleasure. So today, Attunity CloudBeam is offered as a service. And then on the 8th of May, Attunity will also be introduced via the Amazon Marketplace. Within the Amazon Marketplace, for the Replicate solution set, solutions start at $2.08 an hour when replicating to Redshift. And then there's a bring your own license option as well. For the structured data, solutions start at 36 cents an hour. If there are short-term needs, customers can start within just minutes using the Attunity CloudBeam solution today. Okay. Handle one. There's a question coming in. Do you have Another product that would handle a one-time migration to Amazon. The solutions you're seeing today are used for a variety of use cases. It includes ongoing replication, and then there are quite a few customers that find the benefit in using Replicate as a click-to-migrate solution. It takes just minutes to set up, and then you can use it just one time to go from on-prem up to Amazon. There is a question regarding network speed required for ongoing replication. There is no one exact answer. The answer is, given any network speed, Attunity has optimized, will optimize the bandwidth given to it. We will apply that a variety of mechanisms, including compression, multi-part transfers, concurrent sessions and streams. So if you give us a direct connect, we will exploit it. If you give us low latency over a satellite connection, we will still guarantee delivery. Can Cloud Beam replicate from S3 buckets in one AWS region to S3 buckets in a different region? Indeed, that is supported, and it's an extremely common use case.
Brad, this is Maya. I would like to jump in and remind everyone that we are getting extreme amount of questions, and this is great, but in case we won't have time to answer them all, I would like everybody to know that Attunity will reach out via email to everybody, and all questions will be answered within a few days. Now you may continue.
So, Brad,
you,
let me answer a couple of questions.
Sure.
So there is a question that came quite a few times repeatedly about does Attunity have products that will replicate VMs? I assume Attunity doesn't, right?
Attunity can indeed replicate and has quite a few customers that leverage Attunity to replicate images of virtual machines. One of the strengths of Attunity is the ability to break up that file and reassemble it on the target. The outcome be you can have a file maybe 120 gigs large. Attunity will accelerate the transfer of that file, reassemble it on the target, and make it readily available to activate.
But you're talking about the files. Can Attunity take a VMware container and move it and run it on AWS?
Not out of the box per se. It's maybe a matter of a pre-command run the difference between the source and target, and then a post-command to apply the change.
Okay. So that was the question about VM migration. So that's a very repeated question. So Attunity products, at least now, are focused more on data replication and file replication. We will be actually running a very similar webinar on the 30th of this month. That also is around DR, and we'll be featuring a different partner that time. So again, these webinars are not in-depth architecture for DR. So I have a bunch of presentations. Maybe we'll do another one later as a webinar. This is about our partner products. So on the 30th, we have another webinar with a different partner, Cloud Velocity, who has tools and products for migrating VMs. So I would recommend everybody who has questions about that to please attend that webinar. I'll answer one more question before I switch back to Brad. And this question about snapshotting at the RDS level. Does doing snapshot of AWS instance at EBS level or RDS, is it possible while the instance is running? Yes, absolutely possible. That is how pretty much all of our customers do. That's the beauty of snapshotting. You don't need to shut down the instance. The snapshot happens while the instance is still running. There's going to be a slight performance degradation when snapshot happens. So it's a good idea to work that into your snapshot schedule. Back to Brad.
Thank you, Abdul. I see a question here that is something we receive quite often, asking how well does this replication do with millions of tiny files? And Attunity prides itself on being able to handle large workloads. Attunity has no upper limit in terms of the number of files within a source or target, nor the depth of that file system. So of our 2,500 customers, about 50% of the Fortune 100 rely on the Attunity RepliWeb software to handle that size sort of structure within their IT infrastructure. looking still. Continuous replication, what's the RPO on that? With continuous replication, Attunity will recognize any change introduced to the source and in near real time initiate the transfer to the defined target. So there's a few components in play there. The first is reading. That happens virtually in real time. The transfer is optimized between source and target over the connection and then written to the target. So we use the term carefully, near real time with absolute minimal latency. There are, Maya, as you indicated, there's a long list of great questions. I don't know if time affords us the ability to go through all of them, but it's our commitment to make sure that each are answered here promptly soon after the webinar.
Absolutely. Thank you very much for all the effort to answer as many as you could. We did get tremendous amount of questions, more than we are used to getting actually, and I'm very pleased with the engagement. And so our attendees, before you log off, if you have the time, please take a short survey. The link is in your chat box. And thank you all for taking the time to join us today, both our presenters and our audience. Thank you very much, and we hope to see you in future webinars. And our goal is to improve our webinar content. So if you take the survey, there's a space there to indicate verbally what would you like to see different, or what did you really like about it. Thank you very much, and hope to